Welcome to Invested in Climate. Protecting the planet and decarbonizing the global economy is the challenge of our time. We all have a role to play, and the opportunity we face is unprecedented. Invested in Climate aims to help people do more to address climate change through their work, investments, lifestyle, and activism. I'm your host, Jason Rissman. I support a growing community of top climate and ESG leaders as the Chief Experience Officer at Nationswell, and I'm an advisor to the climate practice at IDEO. I'm also an investor and startup advisor, and when it comes to climate action, I know I'll be a lifelong learner, always looking to have more impact. If you like what you hear, give us a good rating on Apple, Spotify, or wherever you found us. Sign up for updates and suggest ideas for future episodes at investedinclimate.com. Follow us on social, subscribe, and spread the word. Thanks for joining.
If you ever remember those days you get to a movie theater, like especially in the spring and the fall, where you're sitting there freezing, they're doing that to get the moisture out of the air, not to make you uncomfortable. So you got to run it in that overcool setting. And so you're wasting energy, you're wasting money, and of course, having more climate impact than you otherwise would need to. What you wish is that you had a way to dehumidify without overcooling. That's basically what we've done here at Mohave. That saves about 30 to 50% of the energy you otherwise would need to use.
Hi, folks. After a summer of record heat waves, I'm sure we're all grateful for air conditioning. And we know it's not just about comfort or productivity, but with extreme heat, being able to cool buildings keeps people safe. And yet, it comes at a cost. Air conditioning today is responsible for about 3% of global greenhouse gas emissions, and demand is set to triple by 2050. Maybe you're thinking that heat pumps are the answer and will come to the rescue. They're certainly an important part of the solution, but until electric heat pumps are plugged into a grid that is fully powered by clean energy, efficiency matters a great deal. Enter Mojave HVAC. Their liquid desiccant technology can cut the energy needed for cooling commercial spaces by 30 to 50%. For today's conversation, I'm joined by Mohave founder and CEO Phil Farese. We spoke about Phil's past and how he learned about the economics of energy efficiency, about Mojave's business model, technology, and potential role in keeping us cool without overheating the planet. Lots to learn in this one. Here we go. Hello, Phil. Welcome to Invested in Climate.
Jason, my pleasure. Nice to get on the podcast.
Great to have you here. Where are you dialing in from today?
I'm at my home in Massachusetts. I kind of right near Boston, split my time between here and our headquarters in Sunnyvale, California, and our manufacturing facility in Anderson, South Carolina. So I travel around a bit.
Thanks, Phil. Glad to catch you while you're not on the road. Let's dive in and learn a bit about you. Tell us about your background and what led you to founding Mohave.
Yeah, certainly. It's fun. I've really kind of built a career that, though I didn't really set out this way or design it that way, really built the expertise that I needed to lead a technical business like Mohave. After deciding to move off the academic path, I was doing a postdoc at Princeton. I went over to McKinsey & Company, fell in love with energy, and had the really satisfying opportunity to lead a piece of work there that we published back in 2010, which sounds like forever ago, that was looked at both the strategic, the technical, practical aspects of energy efficiency from all kinds of viewpoints, from private sector, from public sector, from even nonprofits, and really said, hey, is this a real opportunity? If so, like, what do the costs look like? What do you need to do to make it happen? And then I built on that at NREL, the National Renewable Energy Laboratory, where I was located at their DC office, kind of supporting all four of the energy efficiency programs that the Department of Energy runs. And it was there that I really discovered both liquid desiccant air conditioning and really caught also the entrepreneurial bug. I ended up joining and became the chief technology officer for a liquid desiccant startup in Florida known as Advantic Systems. And then after a few years there, moved on to Enphase Energy, which is, I think, one of the good success stories from sort of clean tech 1.0. It's the company that invented the microinverter for solar installations, mostly for homes and somewhat so for small businesses. And across those kind of two roles in those two companies, I really had just a bunch of amazing opportunities to take on more and more leadership. As I mentioned, I was the CTO. But in addition to technology, at various points, I led product management, sales, program management, business development, regulatory affairs. And then having kind of gotten all that done, was missing a hole in finance there. I actually moved on to Point 72, the hedge fund, where I learned a ton about finance, both the private sector view and the public sector view, as they had both a venture capital group there, as well as, of course, public sector investing. And then I kind of stepped away for a while. I joke I wanted to, at that point, see what I wanted to do when I grow up. And kind of in that downtime, a few months later, Xerox approached me about this liquid desiccant air conditioning technology that they were working on that's now become Mohave.
Very cool. Well, you are in many respects a Renaissance man when it comes to wearing many different hats and having played many different roles in climate tech. Let's turn to Mojave and learn a bit about the company. Let's start off with tell us about the problem that you're trying to solve.
Certainly. I mean, fundamentally, yeah, we say we're trying to change the nature of air conditioning. So, air conditioning is basically a one directional, what you call a heat pump. It does a great job moving heat out of the air that you want to cool and dehumidify and dumping it outside where you're fine to have it happen outside your building. But sort of the real reason, interestingly enough, the Carrier invented this technology over 100 years ago was to dry the air, right? To get the moisture out of the air. And the way it does that, the way that you can really only do that with cooling is to get the air below the dew point. Everybody's familiar with this, whether it's looking at the dew on your grass in the morning or you got a cold drink that you're sitting there in a glass and all that moisture forms on the outside. That's exactly how an air conditioner or vapor compression system, as we call it, cools the air. And it was sort of just the right product until about the 1980s or so. And around the 1980s, we had a lot of changes in how we built buildings. We started really caring about energy efficiency, right? Some of that coming out of the oil crisis of the 70s, and some of it just being modernizing things and realizing that there was a ton of opportunity there. So now the challenge is we've done a great job just getting all this waste heat out of buildings and not producing it in the first place, but you still got to dehumidify. And so now using that same air conditioner, that vapor compression, the only way you can get that moisture out is actually to cool the air too much, especially in commercial buildings. And so instead of installing the right equipment and operating it the right way, like we did for so long, you're now basically installing extra equipment and oversizing things. You're running it colder than you need to. So you kind of, if you ever remember those days you get to a movie theater, like especially in the spring and the fall, where you're sitting there freezing, they're doing that to get the moisture out of the air, not to make you uncomfortable. So you got to run it in that overcool setting. And so you're wasting energy, you're wasting money, and of course having more climate impact than you otherwise would need to. What you wish is that you had a way to dehumidify without overcooling. That's basically what we've done here at Mohave. That saves about 30 to 50% of the energy you otherwise would need to use. And it's giving you the air basically, instead of overcooled and dry, it gives you just at the temperature and just at the dryness that you want, whatever kind of your target may well be.
Thank you, Phil. Great overview. I'm aware that you bring a bit of a contrarian view to the HVAC conversation, or at least some nuance to it. Many are focusing on simply the need to electrify buildings and point to heat pumps as the best way to scale heating and cooling of buildings sustainably. You're arguing that heat pumps have some severe limitations. Tell us more.
Yeah, I would say it's nuance is the right way to think about it there, right? There's great things about heat pumps. We use one, again, the vapor compression system, the air conditioner is a heat pump. Myself, I bought a Dandelion geothermal heat pump for my home in Connecticut because I had oil heat and it was about time to replace the air conditioner anyway. Big investment, long payback time, but massive energy savings, great climate reduction. So there's a lot of benefits there. In fact, Mojave is actually next year going to be launching a product that has a reversible heat pump so you can use it to heat in the winter. I would say one thing I learned in my years at McKinsey and since, like just focusing on one technology too much can lead to a lot of challenges. And I'd say just kind of getting laser focused on improving heat pumps, electrification, kind of overlook some opportunities. And it's maybe a little bit early, right? If you look at the carbon impact of moving from a really efficient gas heater, which you can buy today, to a heat pump, what you're really doing is, right, you stop burning gas on site. And instead, you're now saying, hey, what electricity am I going to get? If you look at what's called the marginal producer of electricity, right? That's sometimes going to be wind, sometimes gas, sometimes coal, whatever it is that's happening in the very complex sort of ecosystem or electrical system that we have, you're going to be using that instead. And I just checked this actually. Most of the time, if you look at, say, PJM in Pennsylvania, or you can kind of do this analysis location by location, a lot of the times you're just switching natural gas on site for natural gas at the facility where you're producing that electricity. The reason that's not terrible, right, is because the heat pump that you're using is very efficient, right? You could almost say it almost seems unphysical, except of course it's physics, so it's spot on exactly what it's supposed to do. But it basically has like a 3x effect, right? For every bit of electricity you put into it, you get 3 times as much work out of it. Now, the challenge is when you burn that gas at that electrical generation facility and then transmit it to the house, it's only about 30% efficient. So in a sense, those cancel out and you're about the same. So when you're kind of using natural gas, it's not too much of a benefit, if any at all. The nice thing is sometimes you're using clean resources like wind, and PJM, it's about 20% of the time right now, or at least the numbers that I looked at. About 10% of the time, though, it's coal, and about 70% of the time that it's natural gas. And so the way that all works out, it's about a wash, maybe 10% energy savings today. In the long run, as the grid gets cleaner and cleaner, that's going to be great, right? Because it really is the only feasible way we know to decarbonize heating, right? Heating is the simplest thing to do. You just burn something, right? But obviously we want to stop burning things. So I think it's a very important thing to do. And it's an important thing to get started on now because it takes a long time to get those things deployed, right? You buy a heater once every 15 years or so. So if we want to have that in the future, we got to start doing it now. But I don't want to do it so much that I'm overlooking near-term opportunities like what Mojave's offering, like all kinds of other things you could do in buildings and transportation and so on that can get us more carbon savings today and frankly continue to get us carbon savings into the future at the same kind of scale that we see with those heat pumps.
Great. Well, thank you for that nuance. Glad to know that you're also a fan of Dandelion heat pumps. We had Kathy Hunan on an earlier episode and definitely cheering them along from the sidelines. I'd love to understand this a bit better. Essentially, you're arguing that while electric appliances like heat pumps pull from the grid that's all often still powered by fossil fuels, it's more important, or at least critically important, to focus on efficiency and just using less energy for our HVAC needs. Why can't we do both at the same time? Why can't we switch to electric appliances that eventually will be powered by clean energy and make those appliances more efficient?
Yeah, no, completely agree. I think you're hitting exactly on it. We need to start building for a cleaner future now and deploy technologies that have a big impact today. And then frankly, cost matters, right? One great thing about efficiency, if you're sort of laser focused on carbon savings without thinking about costs, you get into the situation where, boy, do I really want to make that investment for the good of people? The great thing about focusing on efficiency, and I learned this back when I was at McKinsey, I mentioned we published this report called Unlocking Energy Efficiency in the US Economy. It looked at a broad set of energy efficiency opportunities and evaluated them on a number of dimensions. Basically, if you're asking somebody to invest in efficiency, they need to get a payback. It needs to make economic sense for them. And kind of what we learned there, and I think has continued to hold, is it's got to pay back in about 2.5 years. That's a 40% return on investment. So very, very hard to find a stock that's going to pay that in the stock market. But given the risks, given the point of view of a consumer, that's sort of what you need to do. And I'd say you do even better if you're like a year payback, 18 months payback. And it's not just about the money. So the money's part of it. It's got to be a technology that pays well. It's also got to be something where you're assuring a great customer experience. Lots of great examples in the past of products that have succeeded, even more that have failed because of the customer experience. If you're saying, well, this is a great product, but it's a bit more expensive and you don't really get what you want, but think of how much good you're doing, you can have some impact, but not really at the scale that you want to do to kind of change the economy. And I think that's some of the main learnings we had from Clean Tech 1.0, right? We can't expect customers to invest a lot and sacrifice their experience to save the planet. They need products that deliver all of that.
Phil, let's hear about the technology. How does it work?
Sure. Let me start with what a desiccant is. So you probably are familiar with desiccants, even if you don't know it. Anytime you buy like vitamins or shoes or electronics, they come with these little packets in them. That's filled with a desiccant. It's just something that it's usually a solid, something that naturally pulls moisture out of the air. And you do that because basically moisture damages things, right? You want to keep things fresh. Liquid desiccants are the same thing. They seem a little counterintuitive. The best examples are like the Great Salt Lake or the Dead Sea, where we kind of know those are really, really salty bodies of water, and they just naturally suck moisture out of the air, kind of seeking to equilibrium. And that's exactly what we're using there. The challenge there is, of course, when that desiccant pulls moisture out of the air, it's sort of done. It comes to what you say is equilibrium. And so you got to turn that into a system. And so we've done it in Mohave, and in fact, the others have tried for a long time and had some success at different scales, is putting that into a box that can stand alone and do everything you need to do. And so we basically combined the best of two systems. We grabbed the best thing of an air conditioner, of that heat pump, right, to cool the air and do all the work on the air that we need to do. And then we also put that liquid desiccant system in so that we can get better dehumidification, get those two systems working together. And it's them working together that really allows us to be so efficient, so reliable, and really deliver just air where, frankly, is going to be higher quality, not any user sacrifices, but a user benefit. I can deliver that air at exactly the temperature and dew point that you want and kind of hold that outlet, as we call it, or the supply air that you're getting exactly where you need it to be.
Phil, having worked at NREL, you're no stranger to the long path it takes to develop a technology and commercialize it. So tell us a bit about how Mojave's technology was developed and where you're at with building the business.
Yeah, I got to start with my team. As I mentioned, I kind of came into this in process a little bit there. Rachel Ellman, who actually just today was awarded by HVAC News a 40 Under 40 award. She's our VP of engineering. And she was really the person who took the concept and the ideas that have been kicking around for a while and turned it into a system that is just exquisitely engineered, very reliable, very efficient, very powerful. Paired to her was Aaron Mells, who's our vice president of product. He's worked in a number of startups in HVAC and elsewhere. And he was really the person who could kind of hold the vision for what the product needs to be to get into this, frankly, pretty esoteric and complicated and hard to penetrate market. And I would say it was sort of that pairing of excellent engineering and like true market understanding and an appreciation for customer needs that kind of got this there. This story kind of began in a way almost 10 years ago at Xerox's Palo Alto Research Center under the direction of Jesse Rivest, who now is at Coastal Ventures. The three of them kind of got this to a first prototype point, I would say. So went from a couple different directions they could have gone, from crazy ideas like using it as a battery to a bunch of other things, and settled on this thing that really could be made into a product. And so then in 2022, when Xerox was ready to say, hey, I think we've got a technology here, let's see if we could turn this into a business, through kind of a mutual friend there, they reached out to me. I had known Aaron from before. We were at that company I mentioned earlier, Advantix, that had tried this a bit before. I came out, saw the equipment, met the team, was really impressed with the team and the technology. Still a few challenges to solve that we've solved since then, but was really excited that I kind of said before, it's very rare in life that you get a second chance at things. This was a clear second chance and a very, very strong second chance. And just really excited on everything Rachel had done to improve the technology, everything Aaron had done to get it to be a product that was really ready to go to market. And we were able to kind of take it from there and get moving. We recruited Robert Fancher to lead our manufacturing group and Kyle Troscott to build out our network of manufacturers representatives. So now in just 18 months, basically, we went from pretty much one unit in that Palo Alto Research Center to our own facility where we're now manufacturing and selling equipment. It's super exciting.
Great. Who's the target market, and tell us how our sales progressing?
Yeah. So target market is basically commercial buildings. That can be things like a grocery store, we're really good for, various medical applications like outpatient surgery suites and so on, but also more common things, hotels, offices, multifamily buildings, and so forth. And we're specifically a product that's called a dedicated outdoor air system, a DOAS. The reason for that is pretty much the hardest problem to solve in HVAC. And so sort of the most valuable and also the one we're most suited to. So we kind of went right for that. One kind of before I dive into customers, I kind of say we are very excited about having run a very successful kind of pilot campaign. We've got 30,000 hours on our units across 5 different sites. We got 4 more that we're deploying in the next few weeks or next couple months. So definitely continuing to scale. And I'd kind of lean into that rep network that I mentioned, right? These are kind of the partners that we're very excited about. We went through a very rigorous process to identify them, kind of find people who really got the technology, were excited to move it forward and really align to us from a value standpoint. We've got 18 reps that covers over 50 different offices, well over 300 sales engineers moving product. So a very, very robust pipeline of projects behind that they're really helping us move forward.
Phil, we agreed on the importance of both electrification and efficiency. So tell us, is the product already something that you can plug in, or is it gas powered, or what is the process for turning this into part of that electrified solution?
We have what's called a single point electrical connection. This kind of comes back to the customer experience, right? Our customer is not just the building owner. It's also the people in the building, and arguably most importantly, sort of the engineers that design these things and the contractors who install them. So Aaron did a great job just from the beginning, designing a product that pretty much is a drop-in replacement for what we do today. And this also gets into kind of some of the difficulties around scaling. I say pretty much because, again, it's single point connection. It can go onto a roof or next to a building on what's called a pad. It integrates into a building exactly kind of using the airflows that you're used to using. It's similar size, similar weight to what you would do. It is electrified. It's exactly what you're looking for. And it's very, very easy to just say, oh, okay, I can switch over to this new technology next time I need to install one of these.
Give us a sense of your long-term goals. You've made a clear case for the short-term benefits of looking beyond electrification and considering efficiency as well. What do you see as the overall opportunity for the business and the impact that you can create?
We'll give you kind of a couple time horizons. So kind of first, we're really trying to redefine this product class that I mentioned, the dedicated outdoor air system. Desiccants, and I think liquid desiccants are the right answer. There's other desiccant companies out there, but as you kind of look across pros and cons, I think liquid desiccant is clearly the way to go. This DOAS is the hardest to design, the hardest to operate, the sort of most expensive and therefore most valuable part of a commercial HVAC solution out there. And we're basically trying to redefine that in a way it hasn't been redefined in 40 years. So that's kind of the big first step here to do that in the US. And then I'd say, in a few years, we're looking to get kind of firmly established in the US and then look internationally. We're kind of staying in the US right now, but clearly growth here is in Asia, a lot of opportunities in Europe, and surprisingly, even the Middle East. So kind of looking to expand globally over time. And in the long run, we actually have various ideas about how we can use liquid desiccant and kind of some similar technologies that have been kind of developed as we've walked through this to go beyond this DOAS product category and really change the nature of air conditioning more broadly, right? There's a few different things out there that get back into some ideas that NREL and others before them have had, and that we're also looking at doing and implementing so we can get even more efficient, save even more efficiency, provide an even better experience for our customers.
Size of market and also size of climate impact potential. Do you have a sense of the emissions that could be saved through adopting your technology?
Yeah, totally. If you put our DOAS everywhere that a DOAS belongs, if you will, globally, you're talking about a $5 to $10 billion market, depending how you cut it. and about 100 million tons of CO2 emission reduction per year. 15-year life of the unit, you're talking about 1.5 gigatons over that full area. And then that kind of second leap, if you're really talking about all of HVAC, similar reductions, then you're talking about saving something like a gigaton per year. There's a great piece of work that NREL had done recently, again, with support from Xerox, from Jesse, from others, that pretty much showed the total kind of air conditioning load is about 2 gigatons, and kind of dealing with this dehumidification, et cetera, is a solid more than 50% of that, right? So that's really what we're going after and seeing those kind of savings out there.
Phil, what would you say is driving demand for Mojave's product?
I'd say it's three main things, and it varies a lot by opportunity. There are some people, I'm not going to name any names right now, but we're talking to some big names who at sort of that corporate level are just looking for the climate benefits, right? They have a mandate, and that's frankly something, Jason, that's changed materially in the past 10 or 15 years that I've been doing this. I remember 10, 15 years ago, I would have to be telling people about climate benefits, and they're like, yeah, maybe that's important or not. Now I have people coming to us and saying, we'd like to get some climate benefits. It sounds like you could help us. So I think that's one, is just that kind of pure answer around, hey, we want something that's better for the climate and meets our needs. There's a second one that is kind of more purely economic, which is, wow, we looked at our HVAC bill. We looked at how much it takes to air condition these buildings. It's tens of thousands of dollars per building per year. We have to reduce that. If you can even do half of what you're saying, we're in. So we have other customers who are very much looking at it purely for the operational expense aspect of that and are willing to kind of invest that capital and get the economics of that 40%. We actually often offer like an 80% return on investment. And that's very, very compelling to a lot of, I'd say, more sophisticated building owners and investors. The third area is just problems, right? We've talked to schools, we've talked to other areas where in a given summer, when the building's less occupied, they get mold that forms, they have tens of thousands, if not hundreds of thousands of dollars of mold remediation damage. And they need a way to, frankly, meet the conditions of that building more effectively. Or they've installed equipment and it didn't live up to its expectations, or wasn't designed properly and they're looking for something more, or just kind of looking for, I mentioned kind of we can control temperature and dew point independently, looking for that precise control that frankly I think only we can offer. Since we can dial those in exactly, we can just give you a much kind of more assured airstream, more high quality air to just solve those problems that you have that you don't have a solution to today. So kind of those three things, the climate, the economics, and sort of the customer experience or the benefit of solving the problems that you have are the things that really seem to be driving our customers.
Phil, from the way that you described it, sounds like there might be some debate from a technological perspective around liquid desiccant versus other solutions. And clearly you're on the side of the liquid desiccants, but run us through the pros and cons and where that debate's at.
Forgive me if I get a little too technical here. There are a few different kind of competing technologies here. On the desiccant side, what people are really looking at is sort of a solid desiccant versus a liquid desiccant. They've both been around for a good 20 to 30 years and put in different package solutions, and each kind of have their advantages and their challenges. So I would say with the solid desiccant, the challenge is they can be very hard to what's called regenerate. I mentioned that the desiccant just naturally pulls moisture out of the air. That's great. And then it's kind of full up. So you got to regenerate it. You got to kick that moisture out. And you're typically going to do that with heat. And in order to have an efficient system, you got to use what's called waste heat, some heat that was otherwise going to just be wasted, thrown away, which is what you would be doing with an air conditioner. But again, by packaging together a solid desiccant and an air conditioner, you can take that heat that it was going to throw away and use it to regenerate. A lot of the times the challenge with those is you can't quite get enough heat, right? These solid desiccants typically hold on really, really strong. And therefore you kind of run into some challenges and can't really meet conditions when it's kind of wet and rainy out. I'd say also these solid desiccants have two other drawbacks. They tend to be a bit more expensive, right? Because they're kind of some esoteric chemistries that may come down. I don't think anybody really knows where those are going to land, but the newer things that have better properties do tend to be a bit more expensive. And then if you've ever kind of looked deeply at mechanical systems, like solids are a pain in the neck, right? You got spinning gears, you got belts, you got all these things, you got doors and seals and stuff like that almost always break. So solids are just harder to work with. So on the flip side, right, liquid desiccants solve a lot of those challenges. They're fluids, so they're very easy to move. You take a pump. Pumps are very, very reliable, last 15 to 20 years. The liquid desiccant, though it's a little bit counterintuitive, is actually tunable. So I can dial in exactly the moisture removal that I need without being fixed with that really, really deep dehumidification that I mentioned you get from a solid desiccant. And yet when I need as much dehumidification as I can get, I can just kind of ramp that up by letting it get more and more concentrated. And there allows you to overcome those sort of challenges of regenerating when it's in kind of the wetter, cooler conditions. So it kind of overcomes all the operational challenges and allows us to be very reliable and be kind of very tunable and very able to work in all those circumstances. And therefore also quite a bit more efficient, right? Less heat to regenerate means you can just be more efficient across the board. The one big challenge I would say that sort of held back liquid desiccants over the years is what's called kind of carryover, right? These desiccants are perfectly safe. They're basically salt, right? We use a lithium chloride salt. Other people use potassium chloride or some other commonly occurring salts, all very natural, but they do corrode metals, right? So if you get a little bit of desiccant on like a bare steel, it's going to rust that. And you don't want that to happen for customers. So you got to make sure that that desiccant stays in the system. And we've basically done all the engineering to assure that, right? We test every unit that we're manufacturing right now. We're certain that the air coming out of that desiccant is non-corrosive. And when we deploy here, we deploy what are called kind of test coupons to make sure that that air is staying perfectly clean and not causing any problems. And I would say that's probably the thing that's held the product class back for the past 20 years since it was originally sort of conceived and people tried to move it forward.
You must be used to explaining this to non-technical audiences because despite being technical, that was totally clear and I think probably helpful for our listeners.
Thank you. Yeah, I've done it a few times.
Great. Phil, tell us about the next milestone that you're looking to achieve and the biggest challenges that you're facing.
Sure. Milestone right now for us is basically about scaling. We kind of talked a little bit about our success so far. Again, 30,000 field hours across 5 different sites with 4 more coming up in the next few weeks. We're really looking to get those rep partners. I mentioned we have kind of 18 of them. Some of them are well-known names, like Trane actually represents us in Texas, Oklahoma, and Arkansas. A little bit less well-known is like Tom Barrow, eSolutions, a few others. But in 18 in total, everywhere from Texas to Florida, up the East Coast, and kind of now we're spreading towards the Midwest. Basically, they have some aggressive goals they've set for themselves that we are very excited about. And we're looking to get about 100 units out in the field working by the middle of next year. The nice thing is, as I mentioned, we are manufacturing ourselves and our manufacturing capacity supports that kind of a scale up. I'd also say our customer pipeline is looking strong to support that as well. At this point, we just got to execute, get those out there. And that's really our next big milestone is to get 100 units out in the field on that timeline.
Fantastic. Best of luck on that. Phil, I'd like to zoom out for a bit. The nuance that you've brought to the HVAC conversation is really interesting and helpful, and it makes me curious what else you see as blind spots in our prevailing approaches to addressing climate change, or perhaps buildings more specifically. We know buildings consume about 40% of the energy we use and create about 40% of emissions. Many of my conversations involve some level of frustration about not doing enough or not moving fast enough. And so I'm interested in hearing where you see we're just doing it wrongly from your point of view.
That's a challenging question to answer carefully, so I'm going to be a little careful here. There's often a perspective that sort of the incumbent technologies are not innovating enough, that are very staid, very opposing to kind of new ideas and moving forward. There's some truth to that, but there's also a certain amount of appropriate sort of caution, right? When you're talking about installations in commercial buildings that cost hundreds of thousands of dollars that are keeping people comfortable and sometimes keeping processes safe, you got to be a little bit careful. And I would say there's a bit of improvement that needs to be on both sides of that, right? Entrepreneurs and innovators need to understand, hey, there's a lot of tribal knowledge out there. You really got to take the time to understand what's going on, to think about what those people are facing, to really think about the issues that they face. And I would say incumbents need to say, okay, is there some way where I can test this appropriately to start seeing if this is going to work or not? Let me be open to these new ideas. Let me try to share some of that information so we can kind of get those two forces working together. I would say it's not enough. This is kind of almost like a clean tech 1.0 error. Like you think, I got a great technology. I've got a really great leader who's really inspirational and dedicated to what they're doing. That's sort of all I need. But you really need more than that. You really need to understand all the barriers that you're going to face and learn a couple times now in my life. There's so many different ways to fail and you only need to fail one way to fail, right? So you got to kind of have, in addition to that, like strong business processes, you got to get the team together that can bring all of those things to bear and really kind of comprehensively solve the problem and overcome those things. Again, simple things that you might not think about when you're designing your technology, like how much does this weigh compared to things? Am I going to be too heavy to fit on a roof? Is it going to be too large and therefore maybe work in a lot of places, but really reduce my serviceable market from that kind of $5 to $10 billion that I mentioned before to smaller and smaller amounts? Or electrical requirements, like if I'm drawing a lot more electricity at the peak, or if I have different wire sizes, or I have to change breakers downstream, like all of those details that you just would not think about when you're getting started, you got to find the people who know those things, get them on your team, and then really overcome them, which again is something that we've done. And then of course, just execute, right? You just got to execute.
Phil, a last big picture question. Since you've looked at climate innovation and climate innovation ecosystem from many lenses, from the lens of consulting, academia, government-backed research labs, finance, and now as a climate tech founder, curious of your perspective on this is how do you see the climate innovation ecosystem today and how do you think it needs to improve?
Yeah, I would say, kind of building on that earlier question, definitely a need to get innovators and entrepreneurs to work together more effectively with incumbents, or at least to deeply understand the market that they got and get those right people on their teams. But that sort of team effect, I think, goes even beyond that, right? Which is, in order to really have impact, you need to be able to scale, right? You need to talk about not selling 10 air conditioners, or even the 100 air conditioners that I just mentioned. I want to sell 1,000 a year, right, for the next 10 years. And more than that, 10,000, et cetera. That's what you need to do to really have a large climate impact. And to do that, frankly, you need to build a strong business, a business that is kind of learning appropriate returns, right? I'm not talking about everybody getting filthy rich or anything like that, but there's a lot of people who are kind of betting on your technology and betting on you and betting on your company, whether it's investors, whether it's your customers, whether it's your employers. There's kind of got to be enough value there that all of those people could be appropriately rewarded for the risks they're taking and for the work that they're doing. A hallmark of that is having a strong business. And then, of course, any business needs investors, right? So we need investors out there, whether they're venture capitals, whether private equity, family offices, whomever, who can analyze those risks well and understand them, and frankly, do a good job picking and supporting the winners. I think for every successful company out there, there's another company that should have been successful. And there's probably companies that were successful that shouldn't have been, right? Shouldn't have been backed, but kind of were able to get there and walked a hard path. So finding those investors who could do that and really make a difference by helping to invest in the right companies, I think is super important. I've been super happy with our lead investors, Fifth Wall, At One, MVP, and Starshot Capital. Not only have they invested money and frankly made us introductions to other investors who are interested in investing in Mohave, but they've made connections to customers. They've helped us with some of our business processes like marketing, recruiting, and frankly, they've provided great advice through our board. So really that kind of synergy of finding a way where everybody can win, the customers who are taking the risk to buy your product are getting the returns that they expect, the employees who are kind of pouring their lives and their hearts into it are also getting rewarded, investors who are willing to back you and do that hard work are also on board. I think everybody working together there and taking a true appreciation for how hard it is to do these things and to make these kind of changes is really kind of what it's going to take to get there.
Phil, thank you much for your time today. All the best of luck.
Thank you, Jason.
Thanks for joining us for this episode of Invested in Climate. Please remember to rate us on Apple, Spotify, or Google. Find show notes, sign up for updates, get in touch, and visualize your climate action at investedinclimate.com. This podcast is for informational and entertainment purposes only and does not constitute financial, accounting, or legal advice. Thanks again.